Hello and welcome again. No? And for this video, we'll be talking about least square regression. So this is still part of the numerical method, and this will be the last topic for the midterm, no, for this course. So let's just proceed. Okay. So least square regression from the word itself is least square. So um we are taking uh the least square as a sort for um fitting the data into a a line or a curve or such an equation, such a way um declaring those equation would be the best fit of the data. It said that it should be the very fit equation in which you will have the minimal or the most minimum of error. So yeah, this will be all about the best fit criteria. Um, Most of it will be just curve fitting. So these tools will be useful now in terms of creating predictions out from the data that you created out from your experiment. So yeah, minimizing of the sum of residuals. So from the word itself, you are trying to minimize the error, but it's the sum of the residual errors that we are trying to minimize. And yeah, next one would be the minimizing of sum of error of absolute residual error. So same, but you are just taking the absolute value. So all of these two operations are just taking the difference of error uh, by the difference of the true value or the predicted and versus the actual, which is the observed. And yeah, maybe it could be a reversal way, in which you have the predicted data and you have the observed data. Your predicted data should be the one that you've calculated, and testing the reliability of the one the one that you created from the data would be comparing it with the one that you experimented, the one that you observed, the one that you collected the data from the experiment. So just like that. So calculating the errors would uh create a a an evidence that the predicted or somewhat your calculations are reliable. In the same way, in order to create predictions also, you need to have at least an experimental data. And out from that experimental data, it could be a practical way. So maybe you are opted for this limited form of experiment, and then further into your study, you need to create another experiment in which it would be impractical. But since you have the initial data from your experiment, you could use that so that you could uh, still get some data, which could be the you could create an equation out from the given initial data and put a predictions of your what's called studies. So yeah, so you are just creating some form of formula or some form of equation that would best fit to the actual data. So I hope I make sense for this. So yeah, so we all just want to know the errors, no, because later on when we are applying solver method in Excel, we just want to raise the residuals or the errors into at ato ang ideal should be at the minimum, and perfectly should be at least zero. So perfect, no perfect zero. So supposedly, but we cannot make that because, of course, by nature, the given datas are so random that we could not really get a very precise one. No? Bisa kung saan gina ninyo, there would be variables, there would be errors, no? That you cannot just eliminate, no? And this figure is just the representation to it. The dot points is your experimental data, and there is a line, no? And that line represent as the best fit line of the given collected data. So it means that that line has to whatever randomly lines that you could create inside the plane, that line is the best fit for your experimental data, in which the difference, no, between, or the errors between the dots and the line is at minimum. So what I mean is that ang distance dere as is at minimum. So if you say that you will compare this to a line like this, there will be more errors that you could create, no, because it is not the best fit. Yeah. So this kind of line is what we are looking for, in which we could we could optimize, or we could create the minimal error out from the equation. And we have so-called the SSR. No, this is the sum of the square of the residuals. So sum of the squares of the residuals. So you will add not the squares of the residual. So later on, I will explain you why it should be square, no? It's just to create less error. Mura man na siya, pero by maybe calculation, or maybe by application, we could see why those particular situation are taking square of. So the statistician decide to square those formulas in particular reasons, no? Then we have generalized regression. So this is a conceptual approach. So to any variables of data, we have what we called as the least square solution, and this is done by a matrix algebra, no? And yeah, which is the beta, which is equals to the 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 x, the matrix x, times by the transpose matrix, and yeah, taking the inverse of the matrix times the transpose of the yeah, the matrix, and times the y. There you can see that y is the observation vector, while x is the design matrix, and the beta is the parameter vector, and the last one, the epsilon, is the residual vector. Okay, so coefficient of determination, we have yeah, this is just the r squared, no, in which this has a different formula. Usually if if you take the value of your coefficient, it will be 1 minus the sum of the square of the residuals all over the sum of the squares of the total. So that's it. So I will show you how to do linear regression out from the given, yeah, let's have a experiment, a no, let's have uh a example in which there are datas, and let's see if we could create the best fit equation and maybe use the solver method in Excel. So that is for the next video.